let's talk about something absolutely fundamental in Java I/O, the file class. We're going to break down what it is, and maybe even more importantly, what it isn't. And trust me, getting that difference right is a total game changer for any Java dev. Up until now, pretty much everything your code has done, it's all just lived in memory, right? Every variable, every object, poof, it's gone the second your program stops. So if you want to make anything permanent, you've got to work with actual files on your system. But how? How does your code, which is just this abstract thing in memory, talk to a real physical file on your hard drive? Well, that's the key right there. There's a middle step. Before your program can even think about reading from a file or writing to it or deleting it, it needs a way to represent it. It needs to be able to point to that file's location.
So how does Java handle this? What's the tool for the job? You guessed it, it's the file class.
Okay, so here's the official definition, straight from the Oracle docs. And I want you to laser focus on those first two words, abstract representation. Notice it doesn't say the file or the file's contents. It says representation. That little detail is the most important clue to understanding everything else we're about to talk about.
Let's make this way simpler with an analogy that's going to stick with you. Think of a file object as an address on an envelope. That address tells you exactly where a house is located, right? But the piece of paper with the address on it, that is not the house itself. It's just a pointer. It's just a reference. And here's what that looks like in actual code. Super simple. You just import java.io.file, and then you create a new file object, passing in the name of the file as a string. So right here, what you've just done is create that address object inside your program. It's just a little thing in memory that points to where test.txt should be. Okay, so you've got the address, now what? Well, what's cool is that before you even drive over to the house, you can find out a lot of information just by looking at the address. The file class has a bunch of awesome inspection methods. You can basically ask it questions about the path, like, hey, does anything even exist at this address? That's .exists. Or what's the name on the mailbox? That's .getName. You can get the full detailed directions with .absolute path. You can even ask if this address is for a big apartment building, a directory, or just a single house, a file.
And the crucial thing to realize here is that all of this is just metadata. It's information about the file path. You're not opening the file, you're not reading its contents. You're like a private eye doing surveillance from across the street. You're checking out the address, not going inside the house.
All right, we've set the scene. And now we are at the single biggest point of confusion that trips up new Java developers. I'm serious, if you get this next part, you are going to save yourself so much headache and debugging time later on. So let's go back to that line of code, new file test.txt. When your program runs that line, does a brand new file named test.txt just magically appear on your computer's hard drive? The answer is a big fat no, absolutely not. And this right here, this is the aha moment. Just creating that file object does not create an actual file on your disk. And this table just lays it all out perfectly. On one side, you've got the file object. It's just a lightweight little thing in your program's memory. It's the abstract path, it's the address. On the other side, you have the actual file on your disk. That's real physical data taking up space on your hard drive. That's the house. They are two totally separate things. To get the house, you have to take another step. Okay, so we've hammered this home. The file object is just the pointer, the address. So, what can we actually do with that pointer? Let's look at how we can manage real files and directories. These are the action methods. And look at the names. They're really clear. .create a new file, .mkdir for make directory, and .delete. These are the commands that actually go out and mess with your file system. You use your address object to tell Java, hey, go to this location and actually create a new empty file, or go here and make a folder, or even get rid of whatever is at this spot. And if your address points to a directory, you can use .list files to get a whole list of all the other addresses that are inside that folder. Now, before we wrap things up, I want to give you a quick note for the modern developer. See, the file class, it's old. It's been around since Java 1.0, and a lot has changed since then.
And while it's foundational, it has some quirks. The biggest one is probably its error handling. For example, if you try to delete a file and it fails, .delete just returns false. That's it. It doesn't tell you why it failed. Did you not have permission? Was the file already gone? Who knows? It leaves you guessing.
So to fix this and other issues, Java 7 brought in a whole new, much more modern way to handle files called the NIO.2 API, which is centered around something called Path. It's just better. It's more robust, it works more consistently everywhere, and crucially, when something goes wrong, it throws a specific exception that tells you exactly what happened. So pro tip, for any new projects you're starting, you should probably be looking at using Path instead of File.
Okay, so we've covered a lot of ground. If you're going to walk away with just one key idea, what should it be?
It's this right here. The file class is the all-important bridge between your Java code and the actual file system. It's not the destination, it's the map that gets you there. It's the pointer that lets your program talk to the files on your disk.
So, what's the one thing to burn into your brain? It's our analogy. The file object is the address, not the house. As long as you keep that distinction clear in your head, your file handling code is going to make so much more sense.
Which of course leads to the next logical question. We know how to find the house now. We even know how to build it or tear it down. But how do we unlock the front door, walk inside and actually see what's in there? How do we read and write data? Well, that is exactly what we're going to cover in the next explainer.